prisms and cylinders. And so let's refresh our memories to what volume is. Volume is defined as being a measure of the amount of space contained in a solid. So it's how much something will hold. Okay, the label is always cubic units, whether it be cubic inches, cubic feet, cubic yards. It's always cubic units. Where we get the cubic is because volume deals with 3 dimensions, so cubic always means 3. And so let's go ahead and look at this real quick. This is in your book, and this is the first investigation. It says, find the volume of each right rectangular prism below in cubic centimeters. That is how many cubes measuring 1 centimeter on each edge will fit into each solid. Okay, so we'll do this as a group since we've got kind of smaller numbers today. So what do you think the answer to the very first one is? The one that is 2 by 4 by 3 centimeters. How many cubes will fit in there?
20. 24. Oh, 24.
Why is it 24?
3 times 2 times 4.
Right. Because notice here you have 3 blocks. 3 blocks, that makes 6 here in the front. We have a row of 6 here, row 6 here, row 6 here. So you end up having a total of 24 centimeters cubed. What about letter B?
288.
288. Okay, once again, you can count how many you have here in the front. You have 24. Then you have 12 rows back, which would make 288. And then what about letter C?
3,000.
3,000. So you already know this. When you deal with a rectangular prism, the volume is length times width times height. Okay? Your book has chosen to just give you this formula. This formula says you take the area of the base times the height. That's the same thing as length times width times height. Okay, so I don't care which one you use, as long as you use one of those two. So either area of the base times the height, or you can use length times width times height. That is how you find the volume of a rectangular prism. And so now what we're going to do is we're going to look at some corollaries based on this conjecture. And these are all going to be along the same lines. And so if we go ahead and look at the next slide, okay, the next slide says if B is the area of the base of a right prism or cylinder, and H is the height of the solid, then the formula for the volume is once again the same thing. So I don't know if you need to write that down because it's once again the same thing, the area of the base times the height. An oblique prism, what's oblique? Do you remember what oblique looks like? Slanted. Okay, the right, remember, was upright. So the volume of an oblique prism is the same as the volume of a right prism that has the same height and the same base area. Okay.
What's an oblique prism?
So that's what we learned on Friday. And so anyway, that's once again the same thing as the main conjecture. That's why it's called 86C. And the last one we're going to look at on this slide, it says the volume of a prism or a cylinder is the area of the base multiplied by the height. So once again, that's all you need to remember. Area of the base times the height. Okay? Area of the base times the height. So let's go ahead and look at a few examples. Okay? Find the volume of a right trapezoidal prism that has a height of 10 centimeters. The 2 bases of the trapezoid measure 4 centimeters, 8 centimeters, and its height is 5. So if we remember again what the formula was, the area of the base times the height. They've already specified that the front and the back are the bases. So what I need to do is find the area of the trapezoid and take it times what? The area of the trapezoid times what?
6.
Times what?
What?
Okay, real quick. We're going to take the area of the trapezoid times the height. Okay, so let's just focus on the area of the trapezoid. We'll come back to that question. I think you'll see what you should have said. Okay, the area of the trapezoid we know, okay, is 1/2 B1 plus B2. What are the 2 bases? 8 and 4. What is the height of that trapezoid?
Oh, just find me.
There's the area of the trapezoid. That's the area of the trapezoid. So let's go ahead and calculate that. I think some of you are now seeing what we're talking about. So if I have 1/2 of 12 times 5, what do I get?
30.
30. So that's the area, 60 times 2, or 60 times 1/2, which is 30. So that's the area of the trapezoid. Now what I need to do is take that times the height of my prism. So the height of the prism is basically the distance between the two bases. What's the distance between the two bases? 10.
Oh, wait. Oh, gosh, I would.
So what is the volume here?
300.
300 centimeters cubed. Okay, so the area of the base times the height. All right, let's look at another one, see how we do. Find the volume of an oblique cylinder, okay, that has a base with a radius of 6 inches and a height of 7 inches. What? We'll see. Let's see what your book says. So find the volume of an oblique cylinder. So what do we need to do here?
Find the area of the base.
Find the area of the base. So go ahead and find the area of the base for me. Okay? If you want to leave it in terms of pi, that is fine. So go ahead and find the area of the base for me. 36 pi. Okay, so that's the area of the base.
And the height is 7.
And then the height is 7. Okay, so the area of the base, and then the height is 7. So here we go. Area of the base will be 36 pi. Times 7 will be a total of 252 pi inches cubed. Okay. So, questions? Think you can handle that? What do you do with the 9 on that one? That's the slant height, so you don't even worry about it. It's just there to confuse you. It's exactly right. So what you need to do is on page 533 and 534, 1 through 7, 11, and 12.
I don't understand why they have stuff confused. Like they don't want to